Commissioning and integration milestones. Initial configuration and confirming connectivity and visibility of all electronics. Commissioning starts with checking all connectivity, especially fiber connectivity. Integrators make sure that all the devices connected to the head end are visible from data controller. Number two is CW test and compare calculated versus measured results. Now remember, CW stands for continuous wave signal. It's a blank signal and we use it to test the DAS. Engineers will feed a measured CW signal from the head-end electronics and measure the signal going in and coming out of all electronics down to the antennas. Then they will compare the measured signal against the calculated values. It allows engineers to verify if the DAS is functioning as expected. Number three is first phase of noise optimization. As we add electronics to the DAS, it gives rise to noise. This rise of noise can be calculated. Noise optimization is essentially minimizing unwanted signal. Walk test of floors with CW signal. This step is optional and not so common, but I'll go ahead and quickly explain it. It is possible to create a heat map of CW signal on the floor plan with the help of an RF scanner and proper software. This data collection can enable the engineers to verify the performance of the DAS with CW signal. Engineers can then determine if the DAS is performing as predicted during design phase. Integration of carrier's signal source. Once the engineers complete all the steps described above, your DAS is ready to accept carrier signal, which means Sprint or AT&T or Verizon can now join the DAS. We are assuming at this point that the intended carriers have installed and turned up their signal sources at the site. In the next slide, we'll touch upon a few milestones that you, as a project manager, can track, although it's the operators who are responsible for the installation and turn up of signal sources. Second phase of noise optimization. In this phase, we minimize and optimize the noise for individual frequencies going to the signal sources from the DAS, which means the uplink path. Pretty much in all cases, this is done in conjunction with the carriers or operators. Collecting signal data. In most projects, carriers collect signal in the DAS coverage area to validate their expectation and the performance of the DAS. Let's quickly go over carrier RF source installation tracking. Now, carrier RF source installation is not part of the DAS deployment activities. However, in a few past projects, we have seen our customer tracking the progress of carrier activities. It's good to have a bi-weekly or monthly call with the carrier to discuss the progress of signal source installation. So I'll spend a few minutes on this simplified tracker that can be used for this purpose. First one is RF source type, which is important to know. One carrier may decide to install a repeater, another one may want to install a small cell, whereas another carrier may go after a full-blown base station. Different RF sources will have different timelines, so it's important to know them. Equipment ordered. Equipment ordered and delivered is pretty much self-explanatory. We are talking about RF signal source equipment here. Once the carrier gets the equipment in hand, depending on the type of signal source, installation can take a few days to a few weeks. Next, backhaul installation has to be completed so that the RF source can communicate to the core network. You will probably remember backhaul is the connection to the internet. Also remember backhaul is relevant for a small cell and base station only, not repeaters. RF source commissioning involves loading scripts or parameters into the equipment. For base station, this can be quite involved, whereas for repeaters, it doesn't take more than a few hours, if that. Once the scripts are loaded, BTS or a small cell can be turned up. Before this RF source can be called commercially on air, engineers will do a E911 test to see if any user calls 911, her call will go to the correct public safety access point or PSAP. Again, this 911 call Call testing does not apply to repeaters. Once the RF source is turned up, integration into DAS can start. Integration also involves optimization of uplink noise coming out of the DAS and going into the signal source. Final phase is when carrier collects data to see if the DAS is working the way it should be. This is part of their acceptance and testing procedure, or ATP, which you have also seen in the last slide.